All right, electron configuration, lesson 7-9. They got rubbed off already. 7-9. Work on the worksheet. You'll do letters A, B, C, D, F, and G. So you're going to skip E and G for now. But then after the next lesson, you'll do those others as well. So don't cross them out. Just you don't have to do. Just do these letters for right now, and you'll write the electron configuration, and you'll draw the what's called the energy level diagrams. I call it that. Okay. Now, this chapter 7 that we're in, the entire chapter is about the electron. So look, I have a weird angle there, but oh well, I'll just go with it there. This entire chapter is about electrons. Now, every chapter that I teach, I try to take the things that are really difficult, and I try to do them like near the beginning, so that you have time to kind of absorb it and all for the later on in the easier stuff. Well, you'll like this chapter for a lot of reasons. There's almost no math in it. There's a very minor bit of math in one section. I'll say this chapter is like 3 sections. Okay, the second section will have a little bit of math, like just maybe 2 or 3 days, and then the beginning section and the rest of the middle and all the last section have like no math. So I think you'll like it. But one of the hardest things in this chapter is what we're doing right now. And I'm jumping all the way to 7-9 to do electron configuration. It's kind of like to say that from scientists discovering the electron, you might remember who did that? J.J. Thomson. We talked about that a long way back. But from the time that he discovered electrons until where we are today, a lot happened. Quantum physics, quantum chemistry happened, and that's where we end up with our current model. So a lot of stuff that we do before chapter 7-9 talks about some of that history and some important experiments and some neat phenomenon that were discovered, and talking about the quantum. So before we do that, I don't like to go in order. I like to show you the harder part first, then I'm going to kind of go back and show you how it led to this. So anyway, it'll seem strange a little bit to start off, but I think you'll like this. So 7-9, electron configuration. Okay. Electron configuration. Now, this will seem abstract to you, like what in the world? But believe me, I didn't create this. Everybody uses it. But there's a way that we like to tell it. If you, from the UCLA program I work with, there's a teacher there, Larry Walker, that made this up. It's amazing. A little called Hogg Hilton or the Hogg Hotel. Okay, so where in the atom are electrons? That's the big question. Where are they located? You probably remember, and I've shown you something before, when we first talk about numbers, like why is an atom of aluminum Al+3, how many protons does it have, how many electrons? We talked all about that, and that actually will come back in this chapter as well, so you might even see that page, I think near the beginning, or you'll see that in the notes. But anyway, we always said, well, okay, the protons and the neutrons are in the nucleus, or actually a better way to say, they make the nucleus. So like clumped together, the protons and neutrons are the nucleus of the atom. And then we always say, okay, the little electrons are going to like go around the atom. Now, one model of the atom was the last one we talked about, actually, way back in chapter 2, was called the planetary model by Ernest Rutherford, where he said that the electrons in the atom, that they go around the nucleus much like here's your nucleus, we'll say. They surround the nucleus in orbits just like the planets go around the sun. Well, it turns out that is not true. That is not true. How in the world? What is true is, well, our current theory is that the electrons have a different realm of existence. If you ever heard of this quantum science, quantum physics, it's really neat stuff. But in fact, all of science fiction came pretty much from these theories in the early 1900s. Science fiction talked about these things like from being able to beam somebody from one place to another, beam me up, beam me from here to there. Like here you are in one moment, they turn you into energy or light, and then as fast as light, you can go anywhere. You know, you could be on Mars within just a second, and then you rematerialize there. So your matter turned to energy, you rematerialize. All this really weird stuff, science fiction, but a lot of it is based on science. Now, we don't have technology that can do all of that, but it's interesting. I saw an article once that talked about, it said all the things in science fiction that have come true, because there are many of them that really have come true because they're based on the science. Some stuff seems really impossible, like could a person turn into energy and then rematerialize? It seems like we're just a long way off from that kind of technology. How bizarre that would be. But based on Einstein and other scientists, it's a neat thing. Okay, so what does energy and all that have to do? Turning into energy have to do with matter? Electrons are little particles. They're just like this little piece of chalk. Okay, they're like little balls moving around in the area around the nucleus. I'll say that they are out there. That's true. But they have a different kind of existence, like an energy-like or a wave-like existence out there. So, what electron configuration does, and I'll say more about it later, it treats electrons kind of like they were a radio wave. We'll talk more about that for later on. But like when I say that, think of all the radio stations that let me just check. Think of all the radio stations that are in the city right now, or in California. You know, LA. You turn on. You don't hardly even use radio. Like, what's a radio? But if you ever have an old radio dial where you turn it, or in a car, if you go one by one, click, 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 88.1, 88.2, 88.3, 88.4, all the way up to like 105.2, 105.6, 105.7, 8, 9. Every little station. There are so many radio stations. I would say there probably are 100 stations. If you take all the AM and all the FM stations, there's probably 100 stations. And what that means is their signals are going through right now through your room. Because you could tune into any of those. Those waves are in the room. So they're all in the room, but yet they're in different places. So how can that be? So that's kind of like electrons. They're all in this area, but they don't have to take up a big area of space because they can kind of like pass through each other like waves do, because they're in a different realm of existence. How bizarre that is. Okay, well anyway, so electron configuration is a shortcut, actually, a shorthand method to explain where the electrons are. Now I'm going to show you some stuff that you're going to have to memorize it, and you might have to go back, and I don't know if I'll make more than one video part. I'm sure I know it's going to take a few videos to do the whole section, but you might want to go back and look at it again. Okay, make sure you got that. It'll seem strange. All right, here we go. So the way that I like to introduce this is what was used before, the Hogg Hotel, or the Hogg Hilton. And I used to be able to draw my little Mr. Hogg guy here. I think I drew him one day. But let's just see. He has to have a little bit of a little hog beak. They don't have a beak, a little snout, or whatever we call that there. And then we'll put Mr. Hogg. Oh, actually, we're not going to see his eyes. He's going to have sunglasses on. Okay, and he needs a little ear back there. And there he is, and he's going to be real big old fat hoggy sitting there on the beach, his little legs hanging out. We'll put him his little bathing suit on, and oh boy, he's looking really weird. Okay, well anyway, oh well, Mr. Hogg. I'll just put Mr. Hogg there, and there he is lying there on a chair at the beach. And here's the ocean there and all that. Okay, well anyway, here's the deal. So hogs are lazy and smelly. He doesn't look too smelly. He actually looks pretty cleaned up, doesn't he? So let's put some mess all over him. And yeah, okay, now he's been hogged. Yeah. Okay, all that. So now he's nastier looking. Okay, so he's there. He is. The Hogg Hotel was built on the side of a mountain. So I'm gonna kind of draw like a mountain here. Now, if you've ever seen pictures of, and I've actually had a chance to visit before, beautiful in part of Italy, where you'll see in Italy. I've also seen it in Mexico too. But there's some cities where you see the mountains, and they built little houses and stuff right against the mountains. And Guanajuato has that in Mexico. But the idea is, let's just say you have this hotel, and as you go higher and higher and higher up into the hotel, there are more and more rooms, because you start off on the first floor down here. You know, there aren't as many. You're up against a mountain. But as you go higher and higher and higher, there are more and more Each floor has more and more and more rooms all the way up. We can leave, it doesn't matter if the Hogg Hotel's there. Okay. All right. So first of all, you're going to think, as I go higher level, that means an Electron could be at level 1. That could be on the first floor. A Hogg can be in level 1, or a Hogg can be in level 7. Hogg can be in level 11 or level 22. The floor would be like the level it's on of the Hogg. Now, more we'll say about this is, a little rule is, Hoggs are smelly and lazy, okay? So there is no elevator in Hogg Hotel. What that means is, so let's just say hundreds of Hoggs are all sitting out here. Those are like hundreds of electrons. And they're all going to fill up the atom. So all the electrons, when they fill up, they're lazy. So when they go in, they would rather be on the first floor. They don't want to walk upstairs. So, but if the first floor gets full, then they got to move to floor number 2. If that gets full, they got to move to floor number 3, 4, 5, 6, 7, and so on as they go on up. All right. So lazy Hoggs and Hogg Hotel. All right. There's more to this story. Okay. Now, you know, in some of the beautiful deluxe giant hotels, New York, or maybe I'm sure LA or wherever, they'll just have such a big structure that they'll say, oh, I'm in the north wing or the south wing or the west or the east of the hotel. So there'll be like a north tower section, a south, a west, and the east. So north, south, west, east, 4 towers. Well, in the Hogg Hotel, there also are 4, but they're called not north, south, west, and east, but they're called SPDF. How weird that is. So I'm going to try and draw. If you could be in a helicopter and flying up above Hogg Hotel. Uh-oh. My helicopter's looking kind of weird. Now they look kind of helicopterish, right? Okay. So it has a little propeller there too to keep it from spinning. Okay. So anyway, if that goes up above Hogg Hotel, I would imagine you'll see something like this. Now, the picture can't really do it quite as well. But I'll say you have an S section. You have a, you know what? I better draw this over here closer. An S section. You have then a P section. Then you have a D section. And then the marks will be the F section. And I'll have to kind of come up there and do it like this. So this is what I'm trying to tell you. I know this is a weird thing. Why am I making up this shape? You don't have to remember the shape or anything. But let's just say that this is like the staircase. Remember I told you the staircase? Make it a spiral staircase like you see in a lighthouse or something. If you've ever seen that before. So we'll just say that the S section has only 1 room. Okay, the P section actually has 3 rooms. I'll talk about that. I'm going to show you this in a minute. Should be larger than that, I guess. The D has 5 rooms. So see that these look larger than all of these. And then F is the largest that we're going to talk about. So S, P, D, and F. So what this means is any floor of the hotel you go on, well, that's not really true. On the first floor, you'll see in a minute, you only have the S. The second floor only has S and P, SPD, and then SPDF. But as you go to 4 and beyond. But all the floors, so first floor only has S. Second has S and P wing, SPD wing for 3, and then SPDF for 4, and everybody higher will have SPDF, and even more, because it keeps expand. But we'll kind of get to that later on. Okay, so here we go. Hogg Hotel. There's an unlimited number of floors you can go to. I can go to the first floor, the 20th floor, the 80th floor, 55th floor, whatever. But when you go to that floor, on the 55th floor, we'll say, well, now go to the S wing, or the S section, where the S room are, or go to the P section, or go to the D section, or go to the F section. Okay, so Hogg Hotel, they have a lot to do walking up these spiral stairs all the way and then going into their floor. Okay, I guess I'm going to have to erase Mr. Hogg. I'll keep him there for a little bit more. So here's another thing to be aware of. You need to memorize this little diagram I'm going to show you. Okay, the first one is S, P, 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 D, 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 F, 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 F. That little triangle I just drew. Now what is interesting about this, you'll notice, what does this mean? This tells you, if I go to any floor of the hotel, If I go to any S section, there's only one S room. If I go to any P section, there will be three. In the P wing, there are three P rooms. Someone made another analogy, I've seen this before, saying where they call the S the suite, and P are the penthouse, three penthouses. And then I don't know what the D and the F are, but oh well. But anyway, they named it that way. But anyway, so S, there are three P's. The D section has 5 rooms. So I mean, I could actually draw like 5 little rooms. Okay? Or 3 rooms for the P's if I wanted to. Oh, I'll do that. But the S only has 1 room. Okay, that's kind of getting goofy. But D's 1, 2, the whole thing is goofy. So yeah. But you think it's just probably an easier way to remember this crazy system. That again, we did not invent this system. So you have the S, 1 S room. If I go to any floor to the S room, there's only 1 S room. If I go to any floor to the P section, there are 3 P rooms. If I go to any floor, the D section, there are 5 Ds, and then there will be 7 Fs. So notice that 1, 3, 5, 7. It is mathematical, and it will go on. In fact, after S, P, D, F, there comes G. And guess what? There are 9 Gs. Then H, 11. Then I would be 13. But we don't have to worry about those because you're going to find this. All of this is also related to the periodic table. Okay? And you'll find that every atom on the periodic table, all the electrons, even the biggest atom, they would have the most electrons. Well, now there are a lot of others that have been found. But anyway, we'll just say something like, let's just say a gold atom. That's not the biggest one, but there's 79 electrons. But anyway, every single electron on this chart can fit within the rooms, the hotel rooms that will deal with SPDF. So we'll be able to show you that in a moment. Okay, so now you know the hotel and you know how many rooms there are on each of the wings. Now, let me see. Oh, I wish I could sometimes pause this because I have something else going on trying to fix there. I don't have, oh boy. Oh well. Yes, I do have a little thing going on right here at the same time. I'm trying to, okay. Sending a message there. Okay, so here we go. Our Hogg Hotel SPDF. Now, and we got this little thing. Now, there's one more thing I want to show you. And in fact, I'm going to rewrite this SPDF real small on the side. You can see it here. S P P P D D D D D, and then oh no, F F F F F F F. Let's just try to remember that for a minute. I may not run it into my diagram there. Okay. Okay, I'm going to keep that there for a while, but I'm going to come back to it. Now, one more thing to show you, and this is a pretty crazy one. 1S, 2S, 2P. Oh, this is actually on your notes. So you'll see this, we're starting on 7-9, but actually you'll see this diagram right here. But you know, you can draw this diagram, because you can remember this very easy. I'll show you. First, on the first line, you'll write 1S. Second line, you'll write 2S and then a 2P next to it. Then 3S and a 3P, then a 3D. Then you'll write a 4S, 4P, 4D, and then 4F. Then I'm going to write a 5S, 5P, 5D, 5F, 6, they should be lined up, I'm not doing too great of a job, 6S, P, 6D, 6F, 7S, 7P, 7D, 7F. A lot of times when I'm doing this in class, believe me, I tell everybody when I begin this lesson, I say, you need to listen. Do not be asleep this day in this lesson. You need to hear everything I'm going to tell you. Because if you miss this, you're going to be lost. But the good news is it's all recorded. So you can kind of go back and watch it again if you need to. Because sometimes people will be like, wait a minute, what does that mean? Okay, so anyway, well, all right, here we go. I've told you to memorize the Hogg Hotel has a S, P, D, and an F wing. Every floor. Well, pretty much every floor. I'll explain that in a minute. But in any floor you go to, if it's the 5th floor, 25th floor, 80th floor, there are 3 P rooms in the P section. There's only 1 S room in the S section. There are 5 D rooms in the D section. and there are 7 Fs in the F section. Okay, that's something to memorize. Now, here's another thing. Some teachers don't show this, and some do. In fact, you might see it online written upside down, this right here, and you'll see why in a minute. Now, I'm going to get, here's a green. What I'm going to do is I'm going to draw some little, well, I'll tell you, before I do that, I'll explain what this means. What this tells us is on each floor of the hotel, what room sections do you have? And I just told you this, on level 1, you only have an S section, and it's a single room. But on the second floor, you have S, and you have P. We call it the 2S and 2P. So 2 means second floor, and the S means you're in the S section of the second floor. 2P means your second floor P section. 3S, third level, you have 3S, P, D room sections. Fourth level, you have 4S, P, D, and F. Fifth level, S, P, D, F. 6 S, P, D, F. 7 S, P, D, F. And then it continues to go infinitely, actually, which is amazing. So another thing in this theory that's strange, the rooms, the orbitals for an atom go all the way up, all the way infinitely throughout the universe. You can even say that some of the electrons in your body might have levels in your body that can reach all the way to the moon. Now, what in the world is that? That's some crazy quantum stuff, and you'll kind of get that for later on. But okay, so this tells you what there are. Now, unfortunately, the Hogg Hotel is not as simple as Electron Configuration is not as simple as the Hogg Hotel. What happens is, as Hoggs fill them up, from the bottom floor all the way up, they don't always go in order. Now, they do go in order, but I'll just say that because of the stench, sometimes it smells so bad, and think of like negative electrons, negative to negative. They build up so much in these first few floors that it smells so bad, even for the Hoggs, that Hoggs think, gosh, if I stay here, I have to, it takes me energy just to stay down here. It's so bad. I'll rather use my energy and walk up 2 more stairs and go to a clean air on the next floor. So sometimes they skip around. That's all I'm trying to say. All right. So here is the level. Here's the filling order. So first you're going to draw a diagonal line this way through 1S, then through the 2S, a single. But now you're going to connect. So if a lot of you have amazingly beautiful handwriting, and I know because I've graded the papers, but they should be lined up. You see how I'm doing, okay, I'm lining them up. So there they are. So what this tells us is the order that the rooms are filled up in. What it means is, as the Hoggs come along, first they'll go into room number 1S. When that's full, then they go to 2S. Now, let's talk about what does it mean to be full and all that. Okay, I'm going to use this in small and show you. So the first Hogg will go into, I'll put an up arrow. In fact, I like to also say that in every little line here, S, P, 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 1, 2, 3, 4, and 1, 2, 3, 4, 5, can hold 2 Hoggs each room. Up means it's on the top bunk, and down means it's on the bottom bunk, like that. An up arrow, half up arrow, and half down arrow. So up, down. So after 2 electrons have filled up the 1S, then they move to the 2S. Okay, I'll show you that in a minute. But yeah, I better just draw that right here. Yeah, I'm gonna have to erase this. I'm gonna come back to it. I thought I could do it here, but it won't work out great. All right. So what I'm gonna do, I'm gonna draw another diagram. Now, different books do this in different ways. And they call this an orbital diagram. I call it E-level diagram sometimes, energy level diagram or orbital diagram. But here's what happens. On the very first, at the bottom, you have a 1S room. Then the next floor up, you have a 2S room. Third floor, okay, all right, third floor, but you have 2S and you have also 2P. Okay, so we've got first you fill up, think about like a little slide. You slide into the 1S. They go into the 1S first. When that's full, then they go to 2S. When that's full, they go to 2P. Then they go to 3S. So 1S, 2S, 2P. Then comes the 3S room. Then after 3S comes 3P. Now you're going to memorize this as time goes by. In fact, there's an even easier way to memorize it. After 3P comes 4S. Now, a strange thing is 3p, 4s, then comes 3d, and there's 5 of those, and then you get your 4p's will be up there. I'll draw them, but we're not really going to do anything with 4p in these diagrams. Well, anyway, there should be 3 rooms, 4p, 4p, 4p. All right, 4p, 4p, 4p. So as you go higher and higher up, you have more energy relative to the nucleus. Okay, now let me show you how this works, and let me explain what in the world this is. So I kind of drew this over here. I guess I might have to redraw that again. So, you always want to think, you can always draw this diagram. Like you have a quiz or test, when we're doing this worksheet, homework, you can always just write this thing down. You can also write this down. You probably don't need to write this one down as much. Maybe at the very beginning you will. Okay. So what will happen is, all right, I want to show you. Okay. I guess someone was talking. You might have heard that. But okay. Okay. Here we go. So I'm going to start off with the first element. And you think, well, now I'm finally talking about the periodic table. Okay. So this is something. All right. I'll take a real quick, before I show you this, I want to tell you something. I recommend that if you don't get this, go back and watch this video again, go through it to memorize these sections. But in the next few videos, I'm going to show you a big shortcut, a major shortcut, where you really won't have to do all this stuff so much anymore. But and some people teach that from the very beginning, and you might find it online on the internet or whatever you wanted to. But I always tell people it's better to learn this first, and then I'll show you the shortcut. It's just like in a lot of things you've done in your math classes forever. Sometimes they'll show you the long way, then they'll show you the shortcut. Well, you really need to know the long way here, and then the shortcut will be more meaningful for you. But anyway, okay, here we go. So let's start off with the very first element. It's hydrogen. We're going to go to the periodic table. And we want to say, how many electrons are in hydrogen? Now, my numbers are coming off. I'm going to have to rewrite them there. But, well, this side looks pretty good. But hydrogen is atomic number 1. So, atomic number, the symbol for atomic number is actually a capital Z. It's kind of funny. You might think, how'd they ever think of do that? I guess, like in algebra, X is the unknown. But you've seen a lot of letters in here, like a P, small p is a proton, or small n is a neutron, or capital P is phosphorus, capital N is nitrogen. So we like these symbols. Atomic number, okay, is Z. Number 1 is hydrogen. So hydrogen only has 1 electron. So where will the electron of hydrogen be? It's going to be, Mr. Hogg for hydrogen will go right here, and it'll be an up arrow in the 1s. Now, if I ask you to draw an orbital diagram for hydrogen, you can just do this. You can just say, okay, energy orbital diagram, draw an arrow, the 1s room, and with 1 little electron going up, and I put an E there so they know that's increasing energy. That's the diagram for hydrogen. Now, if you wanted to draw this giant diagram and put 1 electron, you could also do that as well. But all those are empty, so it's not really needed to draw them for hydrogen. You only draw the ones that you have to put. I might use it for other ones, though, to make it easier. Now, the electron configuration, this is the big word here, electron config, for hydrogen is going to be, well, no, Z is 1. I didn't put that in the right place. I put the symbol. But oh well. Atomic number 1. For hydrogen, it's 1s1. Now, what that means is, in the 1s orbital, we call these orbitals, the hotel rooms are called orbitals. And you can also say that the wings, like that will be like that's the S level, or the S wing is the S level. P wing is the P level, the D level, the F level. Now, sub-level is even better. S sub-level, P sub-level, D sub-level, and F sub-level. The level is the floor you're on. So say you're on the first floor or the 10th floor. And if you're on the 10th floor, the level is 10. The sub-level will be 10s, 10p, or 10d, or 10f. Those will be the sub-levels. Now, the orbitals will be the rooms. So you have 1s room. So 1s1 just means you have one electron in the 1s room. So in the 1s room, 1s orbital, s sublevel, you can see all those things. Okay, that's hydrogen. Now the next element is helium. Helium has 2 for the atomic number. So for helium, guess what? It just has one more electron. The first Hogg goes into 1s, the next one goes on the down into the 1s. Each room can hold 2 electrons. Okay, so helium is 1s2. 1s2 is the electron configuration. All right, now let's go to lithium, number 3. Well, lithium is 1s. The first electron goes here. In fact, well, I'll show you that. I'll wait one moment. 1s1, 1s2. The next electron goes, and then you go to 2s1 up right there. So when you write down the configuration, it's 1s2, 2s1. So it tells me that for lithium, the 1s level is completely full, 2 electrons. But the 2p only has 1 electron in it. It still has room for another, which would take us to beryllium, the next element on the chart. Has 4 electrons. And again, because it's neutral. Now remember, I'll get into that. I'll say a little bit of that maybe in this lesson. But because it's neutral, it has 4 protons and 4 electrons. Atomic number, I don't want to be misleading about that. Remember, atomic number only tells you the number of protons in the atom. Now, the protons and electrons will be equal if the atom has no charge. So hydrogen, for example, hydrogen atom has 1 electron. But if you have an H plus 1, remember it loses an electron. And we'll say more about that in the next lessons. Okay, so beryllium has 4. So it will be 1, 2, 3, and 4, like that. So it's 1s2, 2s2 for beryllium. 1s2, 2s2. Okay, now let's see. I think we're kind of getting the hang of it. Well, we better go on. Boron has 5 electrons. So 1, 2. Now, here's something I was going to mention to you if you wanted to. So let's just say that right now I say, okay, draw boron's electron configuration. Okay, what you can do is you can say, okay, there are 5 electrons in boron. So I'll start off 1s. 1s can hold 2 of them. So 1. Maybe you want to draw the diagram like that. Maybe you want to draw out and say, okay, 1s has 2. 1, 2. Then after that fills, now we go to 2s. And it also has 3, 4. Right? There's 5 total. 1, 2, 3, 4, and then 2p. Now when you draw 2p, you actually should draw all 3 rooms, but it's only going to go in the first room. I can draw it up. So 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. That will be boron. 1s2, 2s2. My messy writing there. Okay. Let me skip to oxygen. Let's just, well, actually, no, I don't want to do that yet. Let me do, well, I'll do carbon, then I'll do oxygen, I guess, or whatever, nitrogen. It doesn't matter, whatever. I don't know. I'll do nitrogen. Okay. Nitrogen has 7 electrons. So what that means, 1, 2, 3, 4. Now look at this. Electron number 5, but then electron number 6, electron number 7. Look what is happening. This is a rule. It's actually called Hund's rule. And it says that when you have, we'll look at the Hogg way. If you have 3 rooms on the same level, 3 empty rooms, let's just say you have 3 people. Like, how about this? 3 brothers and sisters. Like, just say 3 siblings. You and 2 brothers, or you and 2 sisters, or 1 and 1, whatever it is. So let's say you have 3. Would you rather all share one room or have your own individual room? You say, oh, I want my own individual room. So the Hogg's the same way. And because of negative electron repulsion, they like to be as far apart as possible. So you have 1, 2, 3. They have separate rooms. Then, after nitrogen, the next electron will now go back and double up. So the ideal is to have your own room. So nitrogen has 7. 1, 2, 3, 4, up, 5, 6, 7. So that will be called will be written as 1s2, 2s2, 2p3. Now, oxygen, the very next element, has 8 electrons. So it's going to be 1, 2, 3, 4, 5, 6, 7. And then I'm going to draw a down arrow, 8. So now the 8th electron is going to share the first room with 1 electron on the bottom bunk. So in terms of electricity and electrical attraction, you know, so 1s2, 2s2, 2p, 4 for that one. So we just total them up. And the p's, you have 1, 2, 3, 4. In terms of energy, you know that negative, negative opposites will attract, but negative, negative will repel. Or positive, positive will repel. Well, it turns out, it's kind of a neat thing in physics, that if you have a negative charge, I'll try to make it, well, I don't know what to use with it, but you have to imagine a ball or my fist, maybe. But if this is -1 and that's -1, they will repel. However, if one of them is spinning, we'll say clockwise, I'm not doing clockwise, that is now. If one's going clockwise and the other one is going counterclockwise, what do I look like? I'm going to try to fight or something. If one's going clockwise, spinning that way, and the other one is spinning counterclockwise, so that means it will be going that way, it turns out, -1, -1, that they will not repel each other. Well, only if they were perfect. If they were perfectly at the same exact speed, going opposite, spinning opposite ways, they can be right next to each other and not repel each other. It's a neat thing about negative charge. So we in chemistry or really physics, I guess you say, the quantum theory, it says, well, these electrons are in the same room, kind of same vicinity. So since they must be doing something different, and it is. There is proof about this, that they have opposite spins. So one has a clockwise spin, and one is a counterclockwise spin. So the up arrow, up means clockwise, and down is counterclockwise. So anyway, that's how 2 electrons can fit in the same room, is because they have different opposite spins. Okay, so we got the 2s2, 2p, 1s2, 2s2, 2p4. All right, now let me jump ahead. And that, what I told you about the Hund's rule happens all the way up. So you can imagine that's oxygen. Then after oxygen comes fluorine. Then comes neon. Okay. And then you go on and on through the chart. And you go through this filling order. 1s fills up. 2s fills up. 2p fills up. Then your 3s can hold 2. Then your 3p is going to fill up. And the 3p's will go 1, 1, 1. Single filled. Then double filled. That's Hund's rule. Okay, then we go all the way up to more and more. Okay, so let's jump all the way to, let me go to titanium, right here, titanium. All right, so I'm going to erase some of this. And, you know, I could erase all of it. I guess I will real quick, why not? We're on the video, you can always go back and, okay. So titanium has 22 electrons. When it's, you know, neutral. So 22 electrons for Ti, titanium. So what that means is, I could just count 22 electrons. 1, 2, up, down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now this is interesting. I know it goes to 4s. Then 21, then 22. You know, we're not even going to use 4p's really here, so I'll just erase them. So notice another thing strange. After 3p, it went to 4s, then 3d. How would you know that? Well, always go to this as like your little law. 1s, 2s. 2p goes up to 6. 1, 2, 3, 4, 5, 6. 3s, 2. 3p, 1, 2, 3, 4, 5, 6. Then notice after 3p comes 4s, then 3d. Okay, 4s, then 3d. And I kind of mentioned this earlier. So it's kind of like saying the first floor fills up with this electron hog stench, smelly, smelly, smelly. The third floor almost fills up. And now a hog walks up the stairs and thinks, boy, this green, it smells so bad. Negative, negative, negative. It's like saying, am I going to be able to put an electron right there? It's kind of like when you put 2 magnets, the opposite sides, you know, you push them and they move apart. That's kind of what's going on. When this fills up, the next electron, it would just push apart. It would just push up to the level 4, and to be safe, to be neutral, to be stable, you would say. Okay? because of the repulsion there, it goes up there. So anyway, or you can say, well, why does it go there? Because that's the order tells me. After 3s, 3p, then comes 4s, and when the 4s fills up, then you go to 3d. Okay, and then once the okay, so back to here again. So the 4s fills up. We said 22. So that was 19, 20 was right in 4s. Then 21, 22. And notice the 3ds, they will also do Hund's rule. 21, 22. And if you continue going, then you'll single fill up. Then you'll double fill up. Okay? So what's going on is, it's like saying when your fourth gets a little bit full with a 4s1, 4s2, now let's just say that the 4s is full, and now the next hog has to walk up. So this hog walks up and thinks, oh gosh, it smells so bad here. If I go up to the next floor, phew, there's 2 hogs up there, it smells bad there too. Well, there's some empty rooms here. They don't have enough energy to jump all the way up, go up the 5th. They don't have that kind of energy. So they'll go right here. So they're going to have to go into the 3D will be full. All right. So, okay. So titanium, 3D, 2. So I showed you. All right. So what you need to do is go through and write down the electron configurations for those elements I told you about. If it didn't, or it kind of disappeared, but I think I can remember. It was A, B, C, D, F, and H. So you'll skip E and G. Yeah, you skip E and G. Now I want to show you one more thing before I let you go. Okay, so what about ions? And you can do a little bit of the ions. I'll tell you tomorrow more about ions. I'll introduce it a little bit. Remember, an ion is an atom that either gains or loses electrons. Okay? So let's just jump all the way, well, I'll tell you what. First, let me go to titanium, actually. Okay, let's do titanium. Titanium can be +2. If I ask you to draw the electron... Oh, no. I'm not going to do titanium. I could tell you right now, make you... Well, I'll wait till tomorrow for that one. No, we're not going to do that. Never mind. I'm going to do the easier one. Okay. That'll be enough for one day. Okay. So let's go and do, for a moment, fluorine, or which one? Yeah. How about fluorine? Oxygen. Oxygen better. Oh, oxygen has, we said, 8 electrons. So 1, 2... So 1, 2, 3, 4, 5, 6, 7, 8. Now that's oxygen atom. If I were to ask you to draw oxide, which you know is O-2, and you have to remember that from last time as well. These are 0, -1, -2, -3, +1, +2. Hopefully you can remember those charges. I'll write them down in case you don't remember. You should know this, at least from last semester. Okay, here they are. So here are the charges. So oxygen forms a charge of -2. So what happens when you become -2? You gain 2 electrons. Okay? So normally oxygen has 8 electrons. 1s2, 2s2, 2p, 4, 2p4, sorry. 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Actually, the top numbers will add up to 8 also. I didn't tell you that earlier. 4 plus 2 plus 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, but O-2 gains 2 more electrons. Now, I would draw them the same way. I wouldn't use a different color, but since I have white chalk, I'll just say we gain 1, we gain 2. So now oxide actually has 10 electrons. So it's going to be 1s2, 2s2, 2p, 6, 7, 8, 9, 10 for oxide. All right. So that's all I need to show you. I don't need to draw anymore. I'll show you the positive ions tomorrow. Don't do the positive ones yet unless you want to look at the video and jump ahead if you're just dying to know, and then you can finish the whole worksheet. But you're not going to do E and G because they have positive ions. I'll talk about those a little bit tomorrow. This is a lot, 45 minutes right now in this one lesson. So anyway, so do that work. Thanks so much, you guys. I think you'll like this. I'll see you.